So in 1897, a scientist named J.J. Thomson was working with what we call a cathode ray tube. And a cathode ray tube produces an electrical current that moves from one end of a glass sphere to the other end. And Thomson was trying to figure out, what is this stream made of? So within the cathode ray tube, there are two deflecting plates, as you can see in the diagram. One's negatively charged on top and one's positively charged on the bottom. So he noticed that as this beam went through the cathode ray tube, it was deflected away from the negative plate and deflected towards the positive plate, meaning that the particles in this beam were negatively charged, and they were coming out of an atom. So Thomson had discovered the first subatomic particle, which he called an electron, which is a negatively charged particle in the atom. Now, they knew that atoms were neutral, so he surmised that there must be some sort of positive stuff filling the atom to counter the negative charge on the electrons. He called this a positively charged pudding, analogous to a cytoplasm in a cell. And he figured these electrons must be floating around in this positively charged pudding. So he drew up a model, and he called it the plum pudding model, after a popular dessert in England at the time. So about 90 years after Dalton, we have our first model of the atom that contains subatomic particles, mainly the electron. And about 12 or so years after Thomson, scientists named Robert Millikan, performed what we call the oil drop experiment at the University of Chicago. He set out to determine the charge and the mass on an electron. And so he determined that the mass of the electron is extremely small, 9.1 times 10 to the minus 34th grams, and that the charge on the electron is also extremely small. As you can see, negative 1.6 times 10 to the negative 19th volts. Now, Millikan didn't derive a new model of the atom, but what he did was show everybody at the time that there had to be other stuff in the atom besides the electron, because the electron had such little mass and atoms were much more massive. So there has to be some other particles in that atom to make up for the mass difference. And there's a picture of Millikan's actual apparatus that he used to determine those values of the electron. So after about 10 to 14 years of studying the electron, what scientists found was that there's got to be other stuff in the atom, because atoms are neutral. And so there has to be a positive particle in the atom to balance out the negative electrons. They also figured out that electrons have such a small mass that these other particles must contain nearly 99% of the mass of the atom. So now they're setting off to discover this big positively charged particle in the atom. And so here we introduce Ernest Rutherford. A couple years after Millikan. Interesting fact, Rutherford was one of Thomson's lab assistants when he did his cathode ray tube experiment to discover the electrons. So Rutherford sets up an experiment called the gold foil experiment, where he basically wants to prove Thomson's model of the atom to be correct. He says, Thomson's his mentor, and so he wants to determine if that is the true model of the atom. So what he had here is a block which emitted alpha radiation. And alpha beams are positively charged. So he was going to shoot these positively charged beams through a thin piece of gold foil. And he expected them to go straight through. And he would be able to detect where they went on this screen. So he said, all right, if the atom is mostly empty space, like Thomson had said, these particles should go straight through the atom, and he should see most of the marks on the back of the screen. There shouldn't really be anything to deflect them. But of course, as is most of the case in science, that's not what he saw. He actually saw a number of deflections as these particles went through the atoms. They actually hit something and deflected off to the sides, and some of them even deflected straight back. And so this is a little description here of what was actually going on in the experiment. So now Rutherford had to determine if most of them went straight through the atom, but some of them were deflected, and very few of these particles were bounced straight back. He had to figure out what's in the atom. And Rutherford's quoted as saying at the time that it was pretty shocking. It's like firing a gun at a piece of tissue paper and having the bullets bounce straight back. You wouldn't expect that to happen, and this is what happened in his experiment. So after time to deduce his findings, he figured out that there is a nucleus in the atom. And that nucleus is very small, and it is very dense, because that's where most of the mass of the atom has to be, because the electrons contain such little mass, and the nucleus is positively charged. A, to balance out the negative charge of the electrons, and B, because most of the particles that he fired through there went straight through. So very few of them actually came into contact with the nucleus, which means that it has to be very small itself. So this is the beginning of nuclear chemistry right here. As Rutherford discovered the nucleus, 1911, and so now he sets off really a whole new field of science. So after Rutherford's test, this is what we discovered, that the atom is mostly empty space, with a very, very small positively charged nucleus in the middle, and electrons that are floating around the outside of the nucleus. As people started looking at Rutherford's model, one person in particular, a guy named Niels Bohr, said, okay, so we got these electrons out there, we got this positive nucleus in the middle, so why don't the electrons fall into the nucleus? Because opposites attract. A negatively charged particle is attracted to a positively charged particle. So they should fall into the nucleus. So he surmised that the electrons orbit the nucleus like planets around the sun. They actually stay in specific orbits, in specific patterns. And he called these orbits energy levels. And so Bohr, just a couple years after Rutherford discovered the nucleus and came out with his model of the atom, Bohr did some experiments and some mathematical relationships and determined that these electrons are indeed in certain energy levels. And so he drew up what he called his orbital model of the atom. And this is the model of the atom that you see pictured a lot of times, where electrons are in specific orbits around the nucleus. And so here's where we are around 1913. This is not the modern view of the atom, as we'll learn in Chapter 4, but this is a model of the atom that we use for a lot of teaching methods.